Right, so 2019, section B, question 3. We have our oblique plane question, okay? So the image on the right shows the entrance structure to the Pilo Hotel, County Meath. It comprises of a series of planar glass surfaces. Figure B3 shows the plan elevation of two of the surfaces A and B. The surfaces are identical and the plan is constructed on the square grid as shown. Draw the plan elevation of the intersecting planes A and B. Well, that part's easy enough. Okay, so scale 1 is to 1, that's grand. So we are going to start off here roughly in the middle of my page, and I am going to keep it slightly towards the right hand side of the page here. Why am I keeping it to the right hand side of the page? Well, just looking at the line of intersection here, so I'm going to probably have to find a dihedral angle sometime, so I'm going to be looking out there, so I'd say just keeping it over to the right hand side. You'll have big sheets, A2 sheets, so you can just work from the middle. But I'm working on an A3 sheet here, so I'm just going to keep it slightly to the right. Okay, I'm going to start here and just mark up. That's that point there. To give me any other dimensions for distance or any other of my points. It tells me 70, so I'm going to mark 70 across here. And I'm going to try and mark up a few of these points here. So this is just drafting it out. This point is up here. This is up 60, and then this is up 40. That's all the points I have in elevation, actually, to be honest. I'm going to come down here to plan, then I'm going to leave just a small gap between my plan. Around 70. And that gives me another point there. Now what are we gonna attempt these questions out here? Well, if we just have a look here, they're giving us a bunch of boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14 boxes. There's 70, so they're all 5mm distances in there. So they're actually giving us the plan in 5mm distances. So I'm going to divide up this. There's 5mm distances there, so then I can sort the rest of this. 1, 2, 3 empty boxes, 1, 2, 3. There we go. Two boxes. Gonna go up 1, 2, 3, 4. 1, 2, 3, 4. It's back here, it goes up 1, 2, 3. 1, 2. Here, and go up to 2. And that's the plan then of my object there. How do I draw the elevation? Well, it's simple enough. I can just bring up those points there. And we can heavy it in. So they've actually a lot of this exam paper here has been redrawn the question, and a lot of it is just setting up the question as given. And this point then, just bring up this base point here. And I'm going to label them in plan, then I'm going to label them A, B, C, D, E, and F. Okay, I'm just labeling for myself. So, determine the dihedral angle between the planes A and B. Well, in order to get the dihedral angle between the planes A and B, what I'm going to do is I'm going to go up 90 degrees to this guy here. Degrees to my line of intersection, which in this case is CD. I'm just going to label these up here. D, C is actually, sorry, that's C. Well, I'll just get this right before I start. This is B. This is C. Oh no, I just want to double check here now. This up to the ground. That up to the ground is C. Bring this up, that's B there. A here, A is actually up here, so I've just actually drawn A in the wrong position. Okay, I'm just drawing A in the wrong position there now. So first you can't rub that out now, but that's A there. Okay, so that's why it's important just to label it and make sure. Here then, E is on the ground and F is up high. And that's my A there. Okay. So again, we're going back up here then. Set up our XY line. So bring up the furthest point up here so it's not right. Okay. So our XY line 90 degrees to that, and we can project up all our points. So that runs through there. So I'm taking all the heights then. I'm going to take the height of D here. Step it off. Label it D. I'm going to take the height of A here, which happens to be the same height as E. Step it off. A and E. Sorry. this is, yeah, this is, just trying to check now. So this is up high, so this is up high, so this is the high one. So that's E and F, yeah, that's perfect, that's F there. So A and E in there. B and F then are on the ground here. That's B and F. And then C then is also on the ground here. So that's C. So I can join them up there. Here we are, because X2, Y2. Okay. So that's my true length of CD. So I've looked up here perpendicular, got true length of CD. And what do I do then? Well, then I do it again. I look along my true length line. Along the true length line. To see my lines as edges. So I'll project up any up there and project up E there. So then I'm going back, then I'm taking the distances from here back. So there's distances from there to there. That gives me a true length line, so that gives me point CD. Okay. And then I go back then and I'm taking that's it. This is from B there. Slipping up B here. Taking distances of A here. I don't know. So look along my true length line here. I want to see A and B there. So I'm going to take distance then from here back to F. And I'm going to, sorry, that's B there. So that's the distance from there. Sorry, from my X2, Y2 back to F. So that's F. The distance from here back to B. Step it out here. That's my B. So I got, yeah, and then I'm going to take the distance from here back, A, from there step it up, so that's my A, that point that was just around there, and then my distance back to E. My compass doesn't actually stretch that far, so I'm just going to take with my set square, so it's 154, and I'm stepping it off up here. Just double check that now. So I'm taking my E distance here, which is, sorry, it's not 154. Look from the wrong line. It's 114. So there. Yep, so they should line up now. So join that back through there. Join this back through. Slight little bit off, but that's my dihedral angle inside there. Okay, so get your length, step it off, get your edge views, and we're done. Right, so that's part B of the question. Part C then is project an auxiliary of elevation of plan A on the line x1, y1, hence determine and indicate in degrees the inclination of plane A to the horizontal plane. So plane A here, so it's this one. The angle is making the horizontal plane. So it's actually telling us exactly what to do here. So what we have to do is just project, get an edge of this plane. So we'll look out along, because we know that if C is on the ground here, it's a true length. So when we look out along that true length, we'll get the true length and the true inclination that plane A has to the horizontal plane. Okay, so check that out there. Set up perpendicular again. And then we're going to take the heights then again. So height to D here. This part is actually very easy. It's told us exactly what to do. C is on the ground. So that's D there, that's C. And then the other point I'm projecting out is E, which in the middle there somewhere. And I bet you if I join D to C, they should all just line up. Slight little bit off. Let's just double check all that again now. So we're just looking for a straight line there. Just double check all those. D. Right, D, yeah. Right of E. Yep, don't know why it's off there now. Just slice it off, but we have D to C, we have an edge view there. And then we just measure that angle there. So the angle is 106. We just indicate that in there, 106 degrees. Okay, and that's it then. That's our part C of the question done. Now part D here then, it's usually a tricky part that they try and throw in. So laser lighting is used to enhance the entrance to the hotel at night. The inclined straight line PQ, which they've given us, okay, represents the path of the laser beam. Determine the points of intersection of the line PQ with the planes A and B. Okay, so I'm going to start by drawing in my line PQ in elevation. Q and P, and they actually give it to us in plan as well. Okay, so it's down 2, 3, 4, 5, 6, 7 boxes. That's in the middle. 1, 2, 3, 4, 5, 6, 7. P, Q. Okay. So what is it looking for us to do here? It wants to know where P and Q hits the line. So P and Q, where do P and Q cut this? Right. So we're given we're given 2 points in plan here. So PQ cuts the plane A here and here. That's not the actual true point that it cuts it. It only cuts it in 1 point, but it cuts it here and here in our plan, and it cuts it here. It cuts B in here and here in elevation. So if we look at projecting those up into our elevation, project those up into our elevation. So that's where DE is. It cuts a DE there, and it cuts FC there. Okay, so if we join those 2 points together, boom, that gives us our point there. That gives the path there, because what we've done is we've actually drawn this line here. This is where it cuts through it. We've found these 2 points and we've drawn then that line there to join another point where they cross. So that point there, that intersection point there, is where it cuts PQ. Okay, once you have that in elevation, you just bring it straight down to plan there, and that's where it cuts our A plane on our elevation. And we're just going to do the same over this side then for our plan. So it's brought up here where it cuts the line D A, cuts the line D A is there, and where it cuts the line CB CB is my ground line. Yeah. So it cuts my ground line here is my other point. When I join them 2 up, then that gives me the point where it cuts my PQ on my B plan. Okay. And Sinead, then that's the question. Just one thing I'm after spotting there now. I'm after making a draft error right at the very start. That's just my fault. It's just something to be careful for you to do. If you haven't started this question, is if you look here, what they done was they split the box here. This third box here, which I missed, so they actually split that box there and shortened that line back there. So that's why this point probably out here didn't line up and these didn't exactly line up here. Okay, so small little drafting errors like that will show you why it will stand out and will catch it out. Won't ever line up perfectly. Okay, but I suppose the important thing is trust yourself in knowing what you're doing and the principles behind everything. So here it was look out perpendicular to the true length, get a true length line, look along it, set up your edge views, get them, and you get your dihedral angle. Same here. So I probably lost a mark or 2 there for drafting at the start, but other than that, you're still talking 98% for that question. Okay.